Good day, learners. In this video, we are going to look now at the next section of the grade 11 analytical. So in the previous video, we looked at the revision exercise based on the grade 10 work. And this second section is still a little bit grade 10 work. Remember now we learned about the three formulas on distance, midpoint, and gradient, these three formulas which you should know. Now we're going to use the same formula, but instead of just asking straightforward what is the gradient, I'm going to ask a bit more difficult questions, like I give you the gradient and I ask you one of the points in rather something like that, which is a bit more difficult. So that's going to be from exercise 1. Okay, so you see, they say in this question it would be helpful to sketch the diagrams. I'm not going to do that, but you can determine the values of K and P if the distance between the points A and B is root 52 units, you see. So normally, you see now the K value there is missing, but they give me the answer. Okay, so I'm going to find the value of K normally if I have the gradient, the distance between point A, B. Let me just write point A, which is 4, -2, and point B, which is at K, -8. Normally, if I have this is x, y, x, y. Once you're uncomfortable with the substitution into the formulas and you know the formulas well, it's not necessary to do this. It's just easier if you start out and you get confused with what to substitute where. This is sort of like a cheat code to help you with the substitution. So normally to calculate the distance of AB, I'm going to take square root of xb minus xa squared plus yb minus ya squared. Okay, so xb is k minus xa is 4 squared plus yb, which is -8, minus ya, which is -2. That's going to change this into a +2. Negative, negative becomes positive. And now this is what it would look like. But now there's a k, you see. Okay, but now what they did is they told me also that AB is a root 52 units. So I have the answer there that I should come to. And now I have an equation in terms of k, like an x, that I should solve. Okay, now since there is a square root both sides, to get rid of that, I'm just quickly going to square the entire side. Then the square would cancel that out. So then I have 52 is equal to k minus 4, and since it's squared, let me somewhere write that twice. K minus 4 squared plus, and -8 plus 2 is -6 squared. Okay, so I'm rid of the square roots, and I wrote that twice, and I just simplified. -8 plus 2 is -6, and now I'm going to just multiply out the brackets quickly as well. So I have k times k, which is k squared, k times -4, which is -4k, -4 times k, which is -4k, -4 times -4, which is +16, and -6 squared is +36. And I see I have a quadratic equation. So for quadratic equations, I need to get everything to one side, 0 on the other. Since everything is already almost here, and I have a positive square this side, I'm just going to jump the 52 over to that side, and I have my 0 on this side. So I have k squared minus 4k minus 4k is minus 8k. And then plus 16 plus 36 is plus, what, 52? Minus 52 is going to become 0. Let me just double check that with a calculator quickly. I have 16 plus 36, and then when I jump that 52 over, minus 52 is going to be 0. Okay, so 0. So I don't have a c value there. Then I can factorize this, and I have k minus 8, meaning that k is 0 or k is 8. Okay. So determine the values of k. That's question 1a. And P, which I'm going to use in question B. Determine the values of K and P. I've got the K can be 0 or 8, which both is fine. And then the value of P, if the point A, this is a different point than that one, new question. This point A that's at negative 3P is equidistant from points C and D. Equidistant means like equal, the same distance. So A is the same distance from C as it is from D. Meaning, if I work out the distance AC, let's just quickly do that. A is the point negative 3P and C is the point 7, negative 1. So if I work out the length of AC, which is XC minus XA squared plus YC minus YA squared. I have something here with a P, but I can maybe simplify this just a little bit at least. To have 7 minus 3 is 7 plus 3, which is 10 squared, that's 100, plus negative 1, negative P squared. Let me just leave it like that. Okay, so AC is going to be that. Should be the same as the distance from A, which is still negative 3P, to D, which is the point 4, negative 4, because A is equidistant to C and D. You see, I'm going to work out the length of AC and I'm going to work out the length of AD. So XD minus XA squared plus YD minus YA squared. And if I simplify this a little bit, I get 7 squared, which is 49, plus negative 4, negative P squared. Right, so AD and AC is the same length, so I can make these two things equal to one another. And since they're both under square roots, yet again, as happens there, I can square both sides, getting rid of the square root. So I'm just going to make the bits under the square root equal to one another. So what I have here is 100 plus negative 1 negative P squared should be equal to 49 plus negative 4 minus P squared, like that. Oh, that's very skew. Sorry, I was now looking there while writing here. Okay, and then you must just solve the equation. I'm sure most of you know how to multiply out the brackets. So I'm going to just quickly do that. Let me just write it with the negatives there. To multiply out, I'm just going to write them twice so that I don't make mistakes here. So I have 1 plus P is plus 2P plus P squared is equal to 49 plus 16 plus 4P is plus 8P plus P squared. If you do need to take a few more steps to multiply out these brackets to there, that's fine. If you do need to pause the video to just quickly do it on your own and see if you get the same, that's fine. But I think most of us know how to do this. So, well, let's get everything to the left-hand side. So this is 101. Plus 2P plus P squared. 49 and 16. I'm just going to quickly check here with my calculator is 65. So 65, if I bring it over, is going to be negative 65. 8P, if I bring it over, is going to be negative 8P. And P squared, if I bring it over, is going to be negative P squared is 0. Right, and then add the like terms. Let's start with the P squared. P squared minus P squared, O is nothing, so that actually falls away. Then the P's, 2P minus 8P is minus 6P, and 101 minus 65 is going to be 36. So plus 36 is equal to 0, and then, well, this is linear, so now I need minus 6P is minus 36, and then if I divide by negative 6 both sides, I get P is 6. Okay, so that's question 1. I'm going to go to question 2 now. Just turn my page here. Okay, so question 2 says determine the values of x and y if it is given that -2, 4 is the midpoint of the line between the points x, y and 6, -3. Let's do this one first. So you see this is the midpoint between the points x, y and 6, -3. Now normally to calculate the midpoint between 2 points, I'm going to write these 2 points down, x, y and 6, -3, right? To calculate the midpoint between x, y, and 6, -3, what I would do, the midpoint is equal to, I add the x's, x plus 6 over 2, and add the y's, y minus 3. It's y plus -3, which then becomes a negative there. Over 2. So this is substituted these 2 points into the formulas. And what they are now doing here is they tell me this should be equal to, they give me the answer. When I simplify this, it should be equal to -2, 4. You see, because -2, 4 is the midpoint. So this should be equal to -2, 4. And then you can see that obviously x plus 6 over 2, when I simplify that, should give me -2. I'm just going to write that here quickly. X plus 6 over 2 should give me -2. And separately, this is something completely separate, y minus 3 over 2. Y minus 3 over 2 should give me 4. Right, and then you have 2 simple equations that you can solve. So to solve this, let me just first get rid of this over 2. Over means divide, so this is divided by 2. To take it to the other side, I'm going to times 2. Then I have x plus 6 is -2 times 2, which is -4. Jump the 6 over, then it's -4 minus 6, which is -10. And there I have same thing. I'm going to multiply the 2 on the other side. Then I have y minus 3 is 4 times 2, which is 8. And then if I jump the 3 over, I have y is 11. So there's the values of x and y. Okay, I'm not going to do b. It's the same thing. You can try it. So calculate the value of x and y. You see here, the y value of the midpoint is missing, so you're going to do that part, you can work out, and the x value of the midpoint is given where there's a missing value on the both sides. So this is a mixture of the two. Let me quickly do this question as well. It's interesting. I like it. Okay, so they say 4, 3 and x7. Number 2b. 4, 3 and x7 is the 2 points given there, and the midpoint is -2y. So I'm going to calculate the midpoint of this by taking the sum of the x's, 4 plus x over 2, and the sum of the y's, 3 plus 7 over 2. This is the formula. Okay, and this should be equal to the midpoint given here is -2y, -2y, right? So this, you see 3 plus 7 is 10 over 2, the y is 5, right? You just work this out, that gives you the y value. So the y value is 3 plus 7 over 2, 10 over 2, which is 5, but the x value you're going to have to calculate like there. So I have 4 plus x over 2 is equal to -2, and then same thing, you calculate the x value. Cool question. Okay, let's end off this video with this question 3. This exercise still has 2 questions on the other side as well there, which you can also look at. Let me just quickly talk you through, show that the diagonals of the parallelogram bisect each other if the points are A, B, C, D. Diagonals of a parallelogram. Let me just quickly draw a picture here. Parallelogram A, B, C, D has diagonals there. You see AC is a diagonal and DB is a diagonal. And if they bisect, that means they cut each other in half. So AC cuts DB in half and DB cuts AC in half, meaning that this point there is the midpoint of AC and also the midpoint of BD. Now, to show that this bisect, what you need to do is you use your midpoint formula to calculate the midpoint of BD, and then separately you also use the midpoint formula to calculate the midpoint of AC, and the coordinates of the two midpoints should be at the same place. Okay, should be the same. So that's what you do for question 4. And question 5, little bit of problem solving for those of you up for the challenge. I'm going to finish off this video with question 3 here. Okay, so question 3 says, given a triangle DEF here with vertices D, E, and F at -3, 6, -2, -3, and F is at x1, with DE equal to DF there, determine the value of x. Right, now if DE is equal to DF, you see I have all of the values of DE, so I can actually calculate the actual length of DE, and then also calculate the length with the distance formula of DF, which that's going to have an x in it, but then I can make the two distances equal to one another to solve the x. So let's do that. I'm going to calculate the length of DE. D is -3, 6, and E is -2, -3. If you still need to write your xy's there on top and write the formula, that's fine. I'm not going to do that now. If you wish to, you can pause the video and quickly just do that first and see if you substitute the same as me here. So I have -2 plus 3 squared, that should be -3, minus -3, and then -3 minus 6 squared. Alright, and then if I type that into my calculator quickly, -2 plus 3 squared plus -3 minus 6 squared, I get 9.055, which I can round to 9.055 rounds to 0.6 units. Okay, so that's DE. Then DF, let me just write F here as well, is the point x1. Yet again, if you need to write your coordinates there and your formula first, you can pause the video and do that. It should be x plus 3 squared plus 1 minus 6 squared, like that. Okay, and then this, well, I can just simplify, write that bracket twice, x plus 3, x plus 3. And this is -5 squared, which is going to be positive 25. Right, now these two things should be equal to one another. I wonder if I shouldn't maybe leave that in root form, just to make the rounding accuracy issues less. That was 1 squared and 9 squared, so 82, root 82. Let me just double check that quickly. Right, root 82. So I'm going to make these two things equal to one another, since it's given information that DE is equal to DF. And yet again, there's roots on both, so I don't need to write the roots. If there's only root on one, yes, you need to write it then and square both sides. But since, let me quickly just write it like that, there's roots on both sides, x plus 3, x plus 3 plus 25. If there's roots on both sides, you can square this side to get rid of the root and square that side, also getting rid of the root. So the root will just fall away. Let me multiply this out. It's going to be x squared plus 6x plus 9 plus 25. X squared plus 3x plus 3x is the 6x plus 9. And Then this is quadratic, so I'm bringing everything over to this side. I have x squared plus 6x plus 9. 9 plus 25 is 34 minus 82 gives me negative 48, 0. And then I'm just quickly thinking 12 times 4 is not giving me 6. 8 times 6 doesn't give me 16. I'm quickly trying to think what I can do to factorize this. 16 times 3 is not going to give me 6. 12 and 4. Let me quickly list here. 48, 1. Then 24, 2. 16 times 3. 12 times 4. 6 times 8. And none of this gives me 6. Did I make a mistake? Not that I can see. Minus 3, 6, minus 2, minus 3, x1. Difference in x. I'm just quickly double checking my work. Difference in y. That's correct. Difference in x. Difference in y. That's fine. Okay, so then I'm going to use the quadratic formula there. Minus b plus minus square root of b squared minus 4ac over 2a. And substitute then minus 6 plus or minus b squared is going to be 36 minus 4a is 1, c is negative 48 over 2a is 1. And then type this into a calculator. So minus 6 plus root 36 just quickly. Then I get 4.549, so that rounds to 4.55. Or if I make that a minus, it gives me negative 10.549, also negative 10.55. Alright, and that is then my answer. Okay, I'm going to stop the video here and then I'll see you for the next lesson in the next video.